The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends over at EOS Positioning. I'm Barbary Duke, Managing Editor here at Directions Magazine with our assistant webinar producer, Lynette Qualia. If you have any questions about your connection, just drop us a note in the chat. We'll do our best to help you. We appreciate that you have stopped by directionsmag.com for more than 20 years. We encourage you to keep stopping by for daily news, webinars, podcasts, and more information. A warm welcome to Jean-Yves Latour, Jeff Shaner, and Yusri Oda. They are here to share their tools and tips on migrating from collector to field maps, along with some very real experiences and best practices. They have so much information for you to get you going. Welcome, gentlemen. We are excited to have you with us today and to learn more about getting started with field maps and GNSS. Jean-Yves, over to you.
Good day, everyone. Hello, everyone. Again, my name is Jean-Yves. I'm with EOS Positioning System. So we're going to start this presentation by just doing a quick overview of how we got here today and the evolution, if you want, of what a field data collection system is. And when GPS started back in the days, that was in the late 80s when the first GPS satellites were launched. I mean, the receivers that came out to receive those signals were just bulky. You know, they were big, they were a proprietary system, and also very difficult to use. There were some windows only because there were so few satellites up in the sky. There were very few windows during the day where you could collect your points. So basically, sometimes you would wake up, go there in the field at 4 o'clock in the morning, bring your foldable chair, get out the 12-pack, and then wait when all the stars are aligned so that you can collect just one point, and you will pop a bottle of champagne for every single point collected. And so it was tedious. So yeah, there was a lot of joy after that champagne, but if you go back to the office, you would have to post-process with another base station that you would have set nearby. And if the data wasn't right, or you would something went wrong, you would have to go back and collect those points. We have very few, a couple of hours windows in the days where you could collect GPS data. And at that time, those systems were expensive. I mean, we could talk about $80,000 US easily for a pair of receivers back in those days. But it was the start, and it was promising, and the GPS constellation was supposed to have 24 satellites total, and with 3 active spares. And so these were the days. This is where it all started. And of course, no productivity, no maps in the field, and everything was proprietary. The data collections computer, if you want, was proprietary operating system. And there was not even DOS in those receivers at the time, in those days, in the late 80s. And after that, it started to evolve. And if we look at the anatomy of a field data collection system, there are 3 components. The first one is the computer, where everything is hosted, where your app is hosted, and that does the communication also with the receiver. The second component is the receiver, of course, that does all the processing of the location and take care of everything, and then sending it back to the computer. And on the computer now you have the mobile data collection app. So all those 3 components make up of a field data collection system. And we're going to see how each one of them has evolved over time. So the first part I'm going to look at are the devices themselves. Back in the days, of course, as I said earlier, they were like very proprietary system, sometimes all in one, everything was included. The receiver antenna was included into just one device, and then by the time you were purchases, then the data collection, the operating system at that time, Pocket PC, that Microsoft had come out, 2000, 2002, 2003, Windows Mobile, 5, 6. Every time Microsoft would come out with a new version of the OS, then old apps would not be able to work anymore. So it was complicated. So by the time, I have to say that these were evolving very fast, and by the time they would come up with new OS, then you would buy an all-in-one receiver. It was already obsolete before you bought it. And another component that came out and greatly helped not only with, it was Bluetooth also. So we started to see more and more field data collection devices, and Bluetooth was integrated in them. And nowadays, you know, your data collection computer is your phone, your smartphone. It's your tablet that you use every day. So nothing complicated. You're in an environment that you're comfortable with, and those are inexpensive. You know, you got a problem with one, then you get another one, you get a rugged case, and then you go in the field to do your data collection. So this has greatly evolved over the years. And the other component of the system is the GNSS. And in the GNSS, we'll see the subcomponents are, you know, of course, the constellations. The GPS, for example, it's a satellite system itself with the ground segments and everything, and the satellites in the sky. And the other component is the receiver itself, and then we'll talk briefly about RTK. But the way GPS has evolved in time, you know, at the early days, again, there was just GPS, and now we have, for GPS constellation only from the US, we now have 30 satellites available. And if you look at the chart on the right side of the slide, this is a chart that we provide every month and update every month in our newsletter. So you can subscribe to the newsletter, feel free, from our website, and then get this information every month along with others. And with that, we see not only we saw GPS modernized with new signals like the CL5, so more signals, more messages that we can use in the field. But we also saw GLONASS, the Russian constellation, come on board in the early days. And now today, recently with Galileo, the European constellation, and Beidou, the Chinese constellation, that gives us over 100 satellites above our heads to play with compared to the 5, 6, 7 we used to have back in the early 90s. So that means that component has greatly evolved, and the GPS receivers themselves have become much smaller and more affordable, of course, and easy to use. And with RTK networks also multiplying across the globe, you have a free differential correction source, so you don't have to, like in the old days, you don't have to post-process your data anymore and export data and then re-import them back into your software and your mapping software. So everything is done. You can get, the GPS receiver will be processing these correction services in real time. And so a lot of them are free in the States. For example, if you look at New York, Florida, they offer free RTK network that also support more constellations than just GPS. So they also support GLONASS, and a lot of them Galileo now, and some of them are supporting Beidou also. So nowadays, 1 centimeter accuracy is available to anyone. And it's before they used to contract out work and to specialize people, and now people can learn how to do 1 centimeter accuracy from a receiver in just less than 1 hour, just a couple of points and guidelines. And the third component of the data collection system is the app. With everything being open right now, like getting RTK, GNSS receiver will not output proprietary messages to a controller. It will output standard NMEA messages that any app can consume. So we saw in the past decade, we saw a lot of companies going there and then making use of this connecting to the receiver and then being able to consume this information and bring to the users an ease of use, if you want, in the field. And Esri, for example, when they released Collector, was able to connect to any GPS receiver in RTK mode, and then you collect your point, and that will go directly to your server. So everything would sync from the field to the office. So no more post-processing, no more handling of your data. It's just you're in the field, you collect the point, and if you get a phone call from your supervisor, you know you have done something bad, and just shut off your phone when you're doing your data collection work. But this is how it is. You just, everything is done. You collect your point, you finish your day, your work is done, nothing else to do, and people at the office can start working immediately on the data that you have collected. So easy to train, and now you have your maps display in the field. So everything that you do, you see it, you visualize it. And so all these combined create what I just said, like a powerful data collection system. Again, and you save a lot of money. You don't, people, what we have seen over the past decade is people hiring even interns or to do the job themselves, go there and collect centimeter accuracy data, including the elevation, and you do it yourself. And unfortunately, the bottle of champagne is kept only for the end of the project, and that's a way to stay sober. You don't have to pop up a bottle of champagne for every point that you collect. You'll be collecting thousands of points for the day. So with this, I will pass it on to Jeff, that will show you the evolution of the field data collection apps that Esri has, field maps and connector and field maps.
Wonderful. So thank you, Jean-Yves. What I wanted to do was start by talking about ArcGIS field maps as a product. For some time, we've been building discrete mobile applications that you can use together to kind of complete a variety of different field workflows. But with ArcGIS field maps, we're bringing those needs together into one focused mobile solution that you can deploy to your field workforce. And over time, adding more and more capabilities to each of these discrete activities. Where we are right now, we did an initial release in November of 2020 that includes the capabilities of 3 different products, namely ArcGIS Explorer, ArcGIS Collector, and ArcGIS Tracker, so that now in one mobile solution, you can sign into the mobile application, discover maps that have been authored for you on your mobile device, use them with your location to kind of discover information, understand in a spatial context what's around you, mark up those maps, integrate with EOS GNSS receivers to do high accuracy data capture, do asset inspection workflows, and record and share your location so that others know where you are and where you've been. As part of our efforts with ArcGIS Field Maps, we've also introduced for the map author a new web application that's integrated into both ArcGIS Online and ArcGIS Enterprise that really lets you bring the maps to life by configuring different capabilities. And I'll talk briefly about that in a minute. From the perspective of the mobile application, there's a rich set of functionality contained within the app. It's built upon Esri's development tools that we provide as part of the ArcGIS platform, namely the ArcGIS Runtime SDKs, and it provides the rich cartographic mapping capabilities that are inside of ArcGIS, along with some of the other really more important intelligence that comes with high accuracy data collection, like our projection libraries, data transformation libraries, and whatnot. From a map viewing perspective, we've also started to support indoor maps, something we won't really talk about today, but if you need to use maps that have multiple floors with indoor facilities, that's available to you, and we'll be bringing indoor positioning in a future release too. For those of you that might have been ArcGIS Collector users and looking to migrate, you now have map markup functionality. So on top of your map, you can freehand sketch, place markers, share images of the map, share that markup peer-to-peer or even back to your ArcGIS organization. Of course, the focus here is for high accuracy data collection, and we've got a variety of different capabilities for leveraging your external GNSS receiver to capture data, but you can also use the map if you'd like. One of the things that's new for field maps that we introduced, and I'll talk about in a separate slide, is a new smart form editing capability. It was our most requested capability as we started to bring these applications together. And you'll see that it's an effort across ArcGIS to bring a robust form editing experience with intelligence to both mobile and web apps. We also, infusing the ArcGIS Tracker capabilities, introduced the ability to passively record and share your location back to your organization in a battery efficient way, leveraging both the location APIs and external GPS receivers, but also the motion APIs that are inherent to the iOS and Android operating system. We've built field maps for both iOS and Android, and in the bottom there you can see our system requirements for the platforms, and more detail about the system requirements are available on our website too, on our documentation website. The exciting, I think, really exciting new capability that we introduced is the web app, and that's designed for map authors, because really it's the map that brings field maps to life, and the layers that you have within your map make collector the asset data collection application or the damage assessment application, and it's all controlled based upon how you configure those maps, both the types or the templates that you use to create new features, or the forms and the form experience that is used for filling out content. It also has the integrated experience for managing your offline capabilities, being able to generate map areas, being able to troubleshoot challenges you might have with sync settings or download challenges. It also introduces the ability to control the functionality that's available in the app. Things like the map tools or the data collection settings, or the appearance and behavior of different actions that happen off of a selection in your map. But what we're here to really focus on is the high accuracy GPS data collection capabilities. And when we're talking to customers, we're seeing a wide variety of needs. Some that use the integrated receiver, but they're doing more observation capture where accuracy is not that important. But then we also see right down to the centimeter level of accuracy for construction-based projects and a variety of different workflows, honestly. Inside of the mobile app, we've built a modest set of GPS capture capabilities, being able to just capture a single point or vertex within a line or polygon with its elevation value. You can capture data on the go using GPS streaming for lines and areas. If you need to use a GPS averaging method, we have that capability. But what's really exciting, I think, is how EOS and Jean-Yves and team have extended the capabilities with much more. Being able to do offset-based collection is really pretty amazing. We do see GPS data capture in a variety of different ergonomic solutions too. Anything from just the use of that integrated receiver on your smartphone or tablet to a pole mount, as you could see here, with a laser rangefinder attached to the pole as well as your device, to a backpack option with the receiver and antenna in the backpack, or as Emma's showing in the picture there, with an antenna attached to your hat. So a lot of different capabilities, even 3D printed attachments. So it's pretty interesting area that we're seeing grow there. One of the few things I have left to talk about, the smart form capabilities I wanted to mention distinctly here. We do have a new way to kind of create and edit form data that's part of the map specification itself. And what's really exciting about this is you can design a form based upon the way that you want your field workforce to be able to enter information, but also you can use that same form to do web editing as well. The form being part of our web map spec means that now you have the ability to use our JavaScript API and build custom web applications, use Experience Builder and the editing widgets that are part of the JavaScript API for that, or the new map viewer as well. So you can provide this form editing experience that crosses both mobile and web applications. What we hear about a lot, though, is about migrating from ArcGIS collector to ArcGIS field maps. And I've just started running a little video in this slide that is showing you the applications side by side on an iPad. And you can see the similarities in use. You can actually install the applications like you see in this video side by side. It has the same user licensing if you'd like. You can complete the same workflows. You can simply download the Field Maps application, sign in, and start to use the maps. And you can take advantage of the new capabilities that we're bringing forward as you're ready to do so. We do have a migration guide available, and that migration guide is a part of our documentation effort, and it's going to be shared as part of the resources that you can pick up with this webinar. Be interesting to get a sense of who knows which app is which on the screen. Maybe that's a final FAQ question we could ask. Last thing I wanted to mention before we go on to the next section is our roadmap. We just launched this week an early adopter program for our next release. ArcGIS Field Maps releases quarterly. We just had a release in September. Our next release is in December. And a lot of the near-term features listed here are already available in a beta format if you're using ArcGIS Online. That includes a brand new experience with our Android application. It has a host of new functionality inside of it. It has the ability to set categories that annotate tracks when you're using location tracking. For those that need to use conditional visibility, but don't yet know or understand the arcade expression language, we're providing a builder experience that will write the arcade on the fly for you. And a lot more. You can see, looking ahead in our roadmap, that probably the most exciting feature, I think, listed in the midterm is for form calculations, leveraging that investment in arcade to calculate values on a form. But a lot more in the future. This is just a quick highlight. And with that, I'll send it back to you, Barbara.
Welcome, Esri. And he is going to share with us his roadmap, if you will. He is with Wilmington in Delaware. Well, he is in the thick of things over there in Wilmington and has a great collection of workflows and demos to show us how they are making it work. Welcome.
Thank you. Thank you. Good morning, good afternoon, good evening, depending where you guys are attending this webinar. It's a great pleasure for me here to be talking about our case of achieving real-time as-builts with ArcGIS field maps and using our GNSS receiver. My name is Esri Odi. I'm a GIS technician in the city of Wilmington. I joined the city of Wilmington 3 years ago. By far, this is one of my most exciting projects that I worked on. Okay, on our agenda here today, I'm gonna just briefly talk about the city of Wilmington and the distribution system in the city of Wilmington. And also I'm gonna talk about our traditional way of updating our water assets using PDF, CAD files, and then GPS. I'm also gonna address the solution that we propose for the city to adopt a new workflow in updating our assets. Then I'm gonna just give you a brief demonstration of our setup of the data on ArcMap, and then how we exported it into ArcGIS Online, and from there, how did we work with the configuration for field maps. The final slide is just a sum up of our achievement from this workflow that we have adopted. So the city of Wilmington is a small city in the north of Delaware. It is almost 17 square miles in area, and it is located in a central location in East Coast, 2 hours drive away from New York, another 2 hours from Washington, D.C. We have a total population of 70,000 residents, and this has been the case for a while. We don't have that much increment on the population number. In the city of Wilmington, we have 416 active water mine, distribution water mine. Also, the city also known as the first city in the first state. So we have a kind of aged infrastructure, and continuously we are working on updating our water mains in the city. These are some of the contracts that I am familiar with. In 2014, we had a contract of replacing 1.9 mile of the small water mains. In 2017, we had another contract to replace 3.5 miles. Then that contract has been extended, and we added to it 1.15 mile. And this year and for the coming year, we are working on replacing 4 miles of the small water mains. And there is a potential for the last contract to be extended with another 25% to be 5 mile replaced. So the oldest active main in our GIS record is dated to 1848. If you want to have kind of a picture of our water mains that it has been excavated, these are the ones. Some of these are wooden. The one in the bottom left is dated to 1850. So first I'm going to start talking about the traditional way of updating our water records. We usually we receive a construction plan or as-built or field sketches as a PDF file, or if we are lucky, we receive it as a CAD file. A third option, we just go to the field and we take shots for this location. And with the CAD file and with the PDF file, the way how we used to work on it, we first georeference those PDF drawings, and by georeferencing those drawings, you introduce a new room for error. You know, the good thing about these, we have a good details of what's going on. Like we have guidance and information about the material and the sizes of the water main pipes that they have been installed. Just the issue with it, it is very lengthy process, and we need to build our attributes from the scratch, you know. So the second option, which is like, I consider it a step forward, which is receiving it as a CAD file. And we're receiving it as a CAD file. If we were lucky and having the correct coordinate system, this will align good with our assets. But in many cases, it wasn't aligning with our assets. It used to be shown as shifted from the actual location, as you can see in the picture in the middle. Also, we have a connectivity issue because these electronic drawings, they were, you know, they were put together by designer for CAD file. And also we are lacking the attribute side of this. So we need to work on that. We usually work on that on making sure that the connectivity is correct and all the attributes are added. So it is still a lengthy process, better than the first one, but it's still lengthy. A third option was us to go into the field and taking shots. So with our legacy GPS, we did not have much options of exporting the data. We had only two choices. One is a CAD file or DXF file. And the other one is a text delimited file, CSV file. And it was kind of a trade-off deciding which one to go with. If you want to go with the DXF file, you get correct geometry. The lines get represented as lines and the points get represented as points, but you are lacking the attributes that tell you which one of the points is valve or hydrant. But if we exported those into CSV file, we can get those attributes, like simple attributes as you see in the attribute table here. But our issue that it's gonna be represented as vertices instead of lines or points. So we wanted a better workflow to get our data updated. So as a solution, the city decided to upgrade our legacy GPS unit. The criteria that I was looking for is first high accuracy. you know, we had a sub-foot accuracy GPS, but if we managed to make it into sub-centimeter, that's even better. And also we were looking for GPS that we can easily implement a new surveying campaign, regardless of what assets we're gonna be collecting. And also I was looking for a workflow that can easily integrate with our data schema. And also we were looking for a GPS where we can use our existing RTK subscription. That was a big part of our decision. And also, because with our legacy GPS, at some point it was functional, but at some point we had to stop using it because many of the telecommunication company are phasing out of 3G. So I was hoping to get a GPS that it doesn't rely on any of those technology, 3G or 4G or 5G, and instead to have it compatible with whatever smartphone that it is paired with. And also we were looking for a workflow that it will enhance the completeness of our data and reduce the errors. So this is the workflow that we have suggested. First, planning ahead, which is where we address what kind of assets we are going to collect. And from there, we moved into replicating the data schema that representing that asset that we have. And from that point, we start thinking about how important is having the metadata fields added to those layers. With the gravitational network for sewer and stormwater, maybe it is a good idea to have the metadata fields, but I'm not sure for the water if it is of a high importance, you know. I just included it in the workflow to have a sense of accuracy. How accurate is the data that I am collecting? And then we're preparing those from either ArcMap or ArcGIS Pro to be published into the ArcGIS Online. And from ArcGIS Online end, we work on the configuration for the web map, and then we access that web map from Field Maps platform to work with the smartphones, the pre-configuration for the default values, and for the forms and templates. There are two additional steps in the workflow. One of them is to configure the EOS to have the RTK correction. And with that, you will need the GNSS information to access the RTK. You will need the IP address or the hosting website and the port. You will need the credential, your username and password. And for the field map application configuration from the tablet side, here where you configure the antenna and the antenna height, and you configure two collection profiles, one of them SPAS and the other one RTK, and here where you put the proper projection that you will use for your data. So the first step in that is very theoretical, but the other ones I'm trying to cover as much as I can in my demo. Here with the thinking ahead, there are multiple levels that you look at your assets. First, you look at a general level, what kind of assets that you are going to collect, and how important is the metadata to be included for that asset. And from there, we narrow it down to the layer level. And here, you decide which layers to incorporate in the collection campaign. You can, for instance, for the water, we have the water pumps and water tanks. We don't often update that layer. So I did not need to have it in my hosted features. So I excluded those layers. And also here you work with the subtypes. What subtypes you want to have them shown for the people in the field map, for the people in the field. So some subtypes sharing some default information, you can combine them into one subtype and they will show up as a template. Some other subtypes, you can just get rid of them if you don't want to show them for the field worker. And also going down more granular to the field level, here where we look at the fields that they can be pre-populated with the default values. And also we look at our data if we have subtypes and domains that we want to have them transferred into the online platform. So here I'm gonna start the demonstration, and it's gonna be 3 sections of the demonstration. One of them from ArcMap, and this is gonna be brief. I'm gonna show you how was the setup that we have done for our project, and then after publication, I'm gonna access our web map and show you what kind of configuration we did from the web map side, and then the third level, which is going to be about field maps and how we did the configuration there for the form and for the templates. Okay, let me access my computer. Okay, so here this is from ArcMap. This is where we prepared the hosted feature, and what we did is we just copied the data set that we have in our GIS database, and we just pasted that into a new file GIS database. And the way how we did that, the reason why we did that, because we want to have all those domains loaded into our new project. So once we had that, we ended up with layers with records, and we gone by them one by one. We selected all the records, we deleted them because these were just copies. We want an empty layer that it has the data schema that we have. So in case in the future, when we did the data collection and loading that data into our system, the fields gonna be mapped one-to-one without having any issue. And also I decided to include the GNSS metadata. An important thing to remember here, the metadata can be tied only to the point layers. So there is an easy tool that is provided by EOS, and here where it load all those fields into the point layer. I already did that, so I'm just going to show you the result, how it's going to show from the attribute table side for the hydrant. Here at the end, we're going to have all those fields added, and these fields going to be auto-populated as we are collecting data in the field. It is a good way to have those, just to give us some sense of the accuracy for the data that we have collected. Another important thing here you can work on is if you have subtypes that you don't want to show them for the people in the field. For instance, here, the fitting, I can just get rid of the service connection, because these are usually from the private side of the city and we do not take shots for that. So I can just like go to the symbology and take that class out of my symbols. So once the map is ready here, you just publish it as a feature service to your ArcGIS account. And from your ArcGIS account, it's gonna be, I usually, the way how I do it, I just get it from my content and I just place it in one of the folders here. It's easy to find it when I need to do any work on that. This is the one I published it earlier for this, for the projects that we are doing. And from the ArcGIS Online, here we need to work on how to make the job easier for the people in the field. So we're going to work on the naming convention and how to change those names, because when they're going to show in the map here, those layers, they're going to be shown with their generic name. As you see here, these are long names. So we're going to make them more meaningful names, so that it's easier to access and easier to navigate through that app for the people in the field. And another thing here we can address is working on the pop-up menu and doing the configuration for the pop-up. And here you can elect to hide those fields that you are not anticipating them to be collected in the field. Again, this is like a way to make it way easier for the people in the field. And once this Once this setup is ready, you just save it as a new web map in your content. And from here, this is where you can access the map that you already have in your content. Sorry. So this is how you access it from Field Maps platform. And from Field Maps platform, here it's going to show you all those web maps that you have. And this is the one I made it for the city of Wilmington to use it for data collection. Here at the overview, this is where you provide some general information about the map, and you can change the settings if you want to share it, if you want to make offline enabled or disabled. That's from the overview menu. And here, moving to the content, this is where most of the work is being done. This is like the part of the configuration that it looks like Survey123. It's going to show you here at the left menu all the layers that you already have in that map. And for all those layers, you can just click on the layer and it's going to show you the form. These are the forms that I prepared from the office so that they're going to be shown from the field worker side. And this is a pretty easy way to configure your collection form. You can add any group here, and within that group, you can include any variables or attributes you want them to be collected. If you look here, I had two groups. One of them is an asset profile, and that gives us more information about the assets that we are going to collect. And the other group is the task profile, which is like more like a record of the project that we are doing the collection for, and the year that we have done the installation at. You can just drag and drop any fields you want it connected. And once you have it dragged here, you can work on, you can decide to make that required or just like to make it optional for the people in the field to have it filled or not. If you made it required, if you hit yes here, it's going to be like while the people in the field doing the collection, it would not move to the next step until they fill up this field here. So a good thing about the field maps here is that there are templates that you can set up for different scenario for each layer. For instance, here I have, For instance, here I have the service laterals here, and I have two templates for that. One for the domestic and commercial, because most of the attributes for domestic and commercial, the material can be anything and the size can be anything. But for the hydrant here, the material should be always cast iron because that's a city standard, and the size always 6 inch. So I actually can make the default values filled here. When you click on the template here, it's going to show you all the attributes within each template. And here where you set up the default values in this side here. If you want any default values, you can just simply type it. Or if you have it a subtype or domain, like you can just, you can do the drop down menu and select it whatever you want. Here I want it to be hydrant. I want it to be portable water. And I want the material to be ductile iron. And the diameter is 6 inch. So here at the other templates, the one for domestic and commercial, you can see a different set of default values pre-configured. Just gonna scroll down here to show the difference. The subtype always here domestic. This is the same water type, but if you look at the material here, it gets auto-populated as copper. Yeah. So this is pretty much it about the demonstration. I'm just going to switch to the slides. I hope it doesn't start from the beginning. It did. Okay, so this is just to sum up what we have accomplished with adopting the new workflow. First, we have a full control on the workflow cycle of collecting data. We are now more flexible to start any data collection campaign for any assets we want in the city. And also we have improved the submittal of the as-built. Instead of waiting for 1 year to get that first design, then hand it to us, now we can get it in real time or near real time. Also, we reduce the time needed to update our data because we are having the same data schema and all those fields. If we want to load it into our data, it's going to be mapped one-to-one. And also, using the default values, we improve the completeness of the data, the accuracy, and the integrity of our data. Thank you for listening.
And this is Jean-Yves again. Before we go any further with the Q&A, with the questions and answers, EOS did a series of training workshops earlier this year. If you hadn't had a chance to attend them, they are very extensive and they cover various subjects like how to do everything from A to Z using field maps. And also there was one workshop on laser mapping and another one on underground mapping with EOS Locate. So feel free to request those recordings. You have the link at the bottom of the page. They go in details with live demos also from everything that you need in the workflow from A to Z. So feel free to request those recordings. And thank you, Yusri and Jeff also. So Barbara, back to you.
Absolutely. So we have got a lot of questions. And so if I'm going to invite you fellows to turn on those cameras so we can see those beautiful faces, and let's dig in and get to several of our questions here. Yusri, we've got a question for you first. Did you look at any other GPS receivers, and maybe why did you pick what you did? Oh, hang on. Looks like we're not hearing you, but let me get at the button here. All right. Let's try one more time and get to hear you there.
Okay, now it should be working.
Yeah.
Yeah, so this was the criteria that I was looking at as I talked in my slides. I look at other models, but also with economical side, I find it more affordable. Mm-hmm. We don't want those sets that they have the collector and the receiver side. But if there is a model that it is more compatible with whatever smartphone that I have, it makes more sense for me to have that.
Perfect. So, Jeff, we've got several questions for you related to all the collection of apps really that are available over at Esri. So, classic app, collector app, field maps app. Could you maybe speak to the kind of pros and cons of each and how that fits into what people need to do?
Yeah, sure. Just to be brief on it, on the very first slide I had, we talked about individual activities, and we started building apps for each individual activity. A product like Workforce for planning and coordination, Explorer for just viewing maps, Collector for capturing data. One of the biggest challenges our customers faced was each of those apps are kind of sandboxed on the iOS and Android platforms. You need to sign into each one of them individually. You need to download content for each one of them individually, and that duplicates what's stored on the device. So that was the purpose, the reason, the strategy behind field maps and bringing them together. Right now, there's the 3 apps that have been brought together. We're starting to build the integration of Workforce so that you have the concept of organizing your work and the status of a mobile worker from a dispatching and coordination capability. And then navigation, which is the last app, will come later. So that's the reason why we had all of these separate apps. And then we continue to build like specialized data collection apps based upon different workflow needs. And that's where Survey123 continues to grow. That's where Quick Capture continues to grow.
Perfect. Jean-Yves, a question for you about equipment. What would they need from EOS for a sub-foot data collection? And they're interested in pairing that with an iPad and ArcGIS field maps.
Uh-oh.
Oh, we don't hear you. There you go.
I know. So I would invite you to inquire about from our website. There's a contact form that you can fill out, and one person, one dealer will be assigned to anyone who wants to have technical question. What would be the best way to achieve things? And it all depends on a few things, what you have available in terms of RTK network around you. You want to install your own base station, and it will be on the higher end models that we have for RTK that will be suitable for this type of applications.
Perfect. So while I've got you, does GPS averaging in field maps record accuracy information like PDOP? They were thinking that a collector wasn't able to before, and what does that look like now?
Well, this is a question I hate to answer. In the early days, PDOP was extremely important. Right. Nowadays, with the number of satellites that we have available, PDOP is becoming completely irrelevant. So I think the estimated accuracy is I think the first thing that is important. I mean, whether you are in RTK, the differential status mode is the most important. If you're RTK differential, code differential, or float or fixed, that's more important today. The second thing is what is my estimated accuracy on the field? Estimated accuracy you have to take with a grain of salt. It's an estimated accuracy, so it's not the actual accuracy that you're getting. It's an estimate. And PDOP, I don't think that Jeff, you do an average of PDOP, but
no,
I think it has become.
I was just gonna say all we capture is the number of positions that were used to compute the average, and then then you're looking at precision, so we capture standard deviation. So.
Exactly, which is more important than PDOP nowadays, because before PDOP, I mean, right now you open your receiver and then you have PDOP at 1, or sometimes below 1. So,
yeah. Excellent. Thank you so much. So Jeff, back over to you. We have a question about sort of this life cycle of apps over at Esri. Do you think ArcGIS field maps will be able to replace Survey123 in the future? Is there a plan to integrate Survey123 in the aspect of like a smart form type of thing? And they're specifically concerned about metadata and analysis created from that data collection.
When it comes to Survey123, we're not folding Survey123 into field maps. It continues to be a separate product and will continue to grow in capabilities. Consider that it has a web application as well as a mobile application, and it was instrumental for a lot of organizations deploying COVID-safe solutions over the past couple of years. On the smart forms capabilities, it embraces something that's an open standard called XLS forms. And they've been iterating in their development work to expand upon that standard and its adoption. What we're doing inside of field maps has a lot of overlap with that, but it's about providing a standard for smart forms that's within ArcGIS. And that's why I was talking about it being part of the web map, being able to use it in web applications as well as mobile applications. I'm sorry, I don't know how to answer the metadata question though. I'm not, maybe that's something we could follow up with offline. I'm not sure what's
absolutely. Yeah, so we've got so many questions from our audience, and just a reminder to folks that we are going to share these with the whole team and expect them to follow up with you, especially if it's something really specific and then maybe they need to do a little research. They're always good about that. All right, Yusri, a question for you. Did you take shots over the assets in the trench, or do you do offsets from the top of the trench?
We used to do offset from the trench. We did not take it from the top.
Excellent. And last question for Jeff. There is, it looks like an iPad LiDAR option available that someone has shared, and maybe you could speak to that.
Yeah, Apple with the iPad Pros and with starting, I think, with iPhone 12s introduced a LiDAR scanner inside of the camera. We've been looking at that. We've been prototyping. It was part of that long-term roadmap item of augmented reality. We were looking at it from a bunch of different contexts, one for data collection, one for just draping and creating an AR-based view, another for doing kind of accurate measurements through the lens of the camera. What we've found so far in our testing is that maybe from an AR perspective, it could be quite useful. We've found for a lot of the workflows that you really needed an offsetting solution, like what Jean-Yves has provided through EOS Tools Pro and being able to integrate with a laser rangefinder.
Mm-hmm.
And that's especially needed when you're trying to capture with accuracy. Mm-hmm. So I don't think we're quite there yet for the workflows we've been looking at for high accuracy anyway. But if you have needs, that's a great follow-up. Love to hear more about where you want to leverage it.
Perfect. So we are out of time. Actually, we're a couple of minutes over, but we appreciate everyone sticking around. Such great information today, gentlemen. Thank you so much. Thank you to the audience for being here today. Shout out to Sarah and Emma for their wonderful support as well. We hope that you will stop by more geospatial webinars. Make it a great day. Tell a friend about EOS Positioning, Esri, and Directions Magazine. Thanks, everyone.